Welcome back to the Troubleshooting series, Part 5, where we shift from broken systems to compromised ones. Over the next 20 slides, I'll walk you through 8 practical signs that a Linux box may be in the wrong hands and how to respond like a calm blue team practitioner. We'll focus on 4 areas: suspicious processes, odd network connections, authentication anomalies, and persistence mechanisms like cron jobs or SUID binaries. Throughout, remember the rhythm: detect, investigate, contain, recover. And the first rule: preserve evidence before you change a thing. Before we go any further, let's be clear about scope. Everything in this series is strictly blue team material: detection and recovery on systems you own and operate. No offensive tradecraft, no malware techniques. Our rhythm is these 4 beats: detect the anomaly, investigate to confirm and scope it, contain to stop the bleeding, then recover by cleaning up and hardening. And the first rule bears repeating: if it looks serious, preserve evidence and consider isolating the host before you start changing anything. So let's apply that rhythm to our first scenario: an unknown process showing up in top or Ps, often with a randomized name. Start by identifying it: PAO to see the command line, LSOFF to see what files and sockets it's holding open, and LSOL on, proc, PID bomb X to reveal the actual binary on disk, even if it's been unlinked. Then, before you kill anything, capture the path and hash the binary. That's your evidence. Only after that do you freeze it with kill, stop, and finally terminate and remove the file. Next, shift from process to network. If your host is reaching out to IPs you never configured, start with SS2NP to list active UDP and TCP connections with the owning process attached. Then filter for estab to focus on what's actually established. Cross-check with LSOFF OIPN to confirm which binary holds the socket. Once you've identified the offender, the discipline is the same: capture the destination first, then contain, block the IP outbound with UFW, kill the PID, and only then dig into how it got there. From the network, move to the front door. SSH, open auth.log and look for the patterns that don't fit. Successful logins at 3 in the morning. Source IPs from countries you don't operate in, or thousands of failed password attempts hammering a single account. Start with last, A to see who got in recently, grep for accepted to confirm successful sessions, and count failed password lines to gauge brute force pressure. Once you've established the picture, contain it. Lock the suspect account with password L, rotate any keys or passwords that may have been exposed, and tighten the daemon. Disable password auth entirely and require keys going forward. Once you've hardened the front door, look for the attacker's back door: persistence. Cron is a favorite hiding spot, so a job that mysteriously re-downloads a payload every few minutes is a classic tell. Enumerate every cron tab you can find, the user's own with cron tab. L, the system directories under or etc. cron. And don't forget system timers via systemctl list unit files. When you spot the rogue entry, delete it, remove the script it calls, then sweep the rest of the host. Attackers rarely plant just one. Persistence often comes with new identities too, so the next thing to audit is who exists on the box and what's running with elevated rights. Dump the account list with cut, then use getint and awk to flag anything with UID 0 besides root. That's an instant red flag. Then sweep the file system for SUID binaries, created more recently than a stable reference file like auth.log hostname. When you confirm a bad account, userdel r removes it cleanly. Chmod US strips the SUID bit from a suspicious binary. And always verify what's left against a known good baseline before you call it done. Shifting from accounts to active workload. When a process you don't recognize is pegged at 100% CPU, you're often looking at a cryptominer that snuck in through the same door the attacker used. Start with top sorted by CPU to spot the offender, then PAS with user, command, and elapsed time tells you who launched it and how long it's been running, while LSOFF shows every file and socket it's touching. Once you're confident it's hostile, kill it hard. Delete the binary, and this is the part people forget: hunt down its cron job or system unit, because otherwise it'll be back within minutes. Now, from runtime back to the file system itself, when a core binary or config has shifted under your feet and the checksums no longer match, you need to ask the package manager what should be there. On Debian, debsums-c walks every installed file and flags mismatches. On rel, rpm-V-AA does the same, and piping through grep for the digit 5 isolates files whose contents have changed. To recover, reinstall the affected package from a trusted repo, apt install -reinstall, or DNF reinstall. And if the tampering runs deep or you can't scope it, don't negotiate with the host, rebuild it. And once an attacker has touched binaries, the next thing they usually touch is the logs. So when var/log looks unusually thin, or journal cdhl -verify reports corruption, or WTMP shows a clean gap right around the suspected event window, treat that silence as evidence in itself. The real fix here is architectural. Ship logs off the box in real time to a remote syslog or central collector, and where you can, mark local logs append only so even root has to work to rewrite history. So let's pull back and look at the full pattern. The indicators worth chasing tend to cluster into 6 families, processes that shouldn't exist, random names, no parent, executing out of /TMP, outbound connections to addresses you don't recognize, especially with the steady rhythm of beaconing, fresh persistence in cron, system units, or SUID binaries you never installed, account oddities like duplicate UID zeros or logins at 3 in the morning, CPU pinned by something you can't identify, and of course those log gaps we just discussed. Any one of these on its own might be noise, 2 or 3 together. That's your signal to open an investigation. And when that signal comes, here's the toolkit you reach for. PS and top show you what's executing right now. SS with TUNP maps every connection back to its owning process. Elizoff bridges the two, listing open files and sockets per PID. Last, B give you the login story, both successful and failed. Find with perm-4000 hunts down SUID root binaries and RPM-VI-A or debsums on Debian systems verifies your packaged files against their known good hashes. 6 commands, no installation required. They're already on the box. But before you run any of those tools in anger, pause and capture state. Dump your process list to a file, snapshot your network connections with SS, copy auth.log somewhere safe, and hash any suspect binary with SHA25P6 sum so you can prove later that it hasn't changed, and whenever you can, push that evidence off the host, because the moment you reboot or start cleaning, leave processes and open sockets are gone for good. Discipline first, action second. With evidence safely captured, containment becomes the next beat. You've got 4 practical levers here. Isolate the host from the network so the attacker can't spread or exfiltrate further. Freeze suspicious processes with kill-stop, which preserves memory for analysis while halting activity. Lock any accounts you believe are compromised and rotate their credentials. And finally, firewall. The external IPs the host was beaconing to, cutting the command and control channel. Pick the combination that fits your blast radius. You rarely need just one. Once contained, you move into recovery. And recovery is really about restoring trust in the system. The honest truth is that a compromised host is hard to ever fully trust again. So when in doubt, reimage it and rebuild clean. Restore data from a backup taken before the compromise window, never after. Rotate every secret that lived on that box. Keys, passwords, tokens, all suspect now. And critically, patch the entry point itself. If you don't close the door they came through, they'll simply walk back in. With recovery underway, the focus shifts to prevention, making the next intrusion harder, noisier, and easier to investigate. Ship your logs off host to an append-only collector so attackers can't quietly erase their tracks. Lock SSH down to keys only and let fail2ban shut the door on brute force attempts. Run AD or tripwire so you're alerted the moment system files change unexpectedly. And keep the basics tight. Patch quickly, trim SUID binaries, and strictly limit who holds root. Let's pull it all together. 8 scenarios, 8 muscle memory responses, an unknown process you trace with PIM and LSOF before stopping it. Odd connections you confirm with SS before blocking. Failed SSH floods that send you to auth.log and lock the account. A malicious cron entry you capture with audit before removing. Surprise users or SUID binaries found with find and cleaned up. A pinned CPU that points to a miner. Modified files verified with RPM and reinstalled. And tampered logs that remind us why central logging matters. Same rhythm every time. Detect, investigate, contain, recover. If you remember nothing else from this session, remember these 4 beats. Detect, then stay calm. Confirm the anomaly is real before you assume the worst. Preserve before you clean. Capturing processes, connections, and logs while they're still live. Contain fast to stop the spread, then rebuild and harden. Reimage when you're unsure, rotate every secret that hosts could have touched, and close the door behind you. Before we close out, here's a quick reference for the vocabulary we've been leaning on. An IOC is any clue that points to intrusion, a strange process, an unexpected connection, a file that shouldn't exist. C2, it's the attacker's remote server, the other end of those outbound calls. IR is the discipline itself. Detect, contain, recover. Persistence is how malware survives a reboot. Cron jobs, system units, SUID binaries, and FIM, file integrity monitoring, with tools like IDE or Tripwire, is what tells you quietly when something on disk has changed. So that's the whole idea in 2 lines. Spot it early, contain it fast. Strange processes, odd connections, mystery logins. You now know the indicators. You know how to preserve the evidence, and you know how to contain calmly and rebuild trust. If this series helped, the full 5 parts are over on Dargslan.com. Classics, cron, and SSH, boot, performance, and this security deep dive. Subscribe, like, share, and I'll see you on the next runbook. Stay disciplined out there.